All right, let's talk about object-oriented programming, or OOP. If you've ever heard that term and thought it sounded complicated, you're in exactly the right place. Over the next few minutes, we're going to break it all down, using Python to turn these big, abstract ideas into something you can actually use. Let's get right into it. First things first, I've got a question for you. What is the actual difference between a recipe for a cake and the cake itself? You know, one is just a set of instructions on a piece of paper, right? The blueprint. The other is the real thing, the actual cake you made. Just keep that idea in your head, because honestly, it's the key to understanding everything else we're about to cover. So that recipe we were just talking about, in the Python world, we call that a class. It is the blueprint. A class doesn't do anything by itself. It just lays out the rules. It says what ingredients you'll need. We'll call those properties, and what you can do with them, which we'll call behaviors. And the cake? The thing you actually made? That's the object. It's a real, specific instance you created from that class blueprint. And you can use that one recipe to bake lots of cakes, right? They're all based on the same class, but each one is its own separate object. Okay, enough with the analogies for a second. Let's get our hands dirty and actually write our very first blueprint. You're going to be surprised by how simple this is. And that's it. Seriously? This is a complete, 100% valid class in Python. The class keyword tells Python we're making a blueprint. We've decided to name it point. And that pass keyword, it's just a placeholder. It literally means do nothing for now. So we've made a blueprint, but it's totally empty. So how do we actually use this empty blueprint? Well, you just call it, kind of like you'd call a function. This line, p1 equals point, tells Python, hey, use that point blueprint to make me a real thing, and then we store that thing in a variable called p1. We've just baked our first cake. We now have a real object, an instance of our point class. Okay, so we have our object, but right now it's basically an empty shell. It doesn't hold any information, it doesn't know anything. The next logical step is to actually give it some data. I mean, we called our class point, right? So it should probably represent, a point on a graph. But how do we tell it where that point is? How do we give it an x and a y coordinate? The answer is with something called attributes, and it's super simple. You just use a dot. That's it. When we write p1.x equals 5, we're basically creating a new variable named x that lives inside our p1 object, and we're giving it the value 5. We do the exact same thing for y. And just like that, our object now has a state. It knows something about itself. Great. Our objects can hold data. But the real magic of object-oriented programming, the whole point of it, is bundling that data together with the actions you can perform on that data. So, we have a point. It knows its coordinates. What kind of things would we want it to do? Well, maybe we'd want a way to move it back to the origin, to 0, 0, with one simple command. These actions are what we call an object's behaviors. We define these behaviors using methods. And really, a method is just a fancy name for a function that lives inside a class. So here, we've added a reset method. When we call it on a point object, it's going to set that object's x and y attributes back to 0. But hang on, what's that weird self thing doing there? This is the part that trips almost everyone up at first. This quote from our source material puts it perfectly. When you run your code and call p1.reset, Python secretly does something for you. It automatically passes the p1 object itself as that very first argument. So inside the method, when you see self.x equals 0, it really just means set the x attribute of whatever specific object this method was called on to 0. And check this out. This slide shows you exactly what's happening under the hood. The 2 lines of code you see here, they do the exact same thing. Writing p.reset is just some nice, clean-looking sugar for point.reset p. See? Self isn't magic. It's just the conventional name we give to the parameter that receives the object instance. So our point class is looking pretty good. It has data, it has behavior, but there's a subtle flaw in our blueprint, a little trap waiting for us, and fixing it is going to unlock one of the most powerful features of all. Just think about it. The way we've been doing it requires 3 steps. First, you create the empty point, then you set p.x, then you set p.y. What if a programmer using our class just forgets one of those steps? What if they try to use the y-coordinate before they've even created it? Well, this happens. Your program just blows up. It stops dead and screams attribute error.
And that's really bad because it means our blueprint allows for broken, half-finished objects to exist. We need a way to guarantee that when an object is made, it's made correctly, right from the start.
And here's the hero of our story, the initializer. You'll see it written as underscore underscore init underscore underscore with those double underscores on each side. People often call them dunder methods. This is a special, magical method that Python guarantees will run the instant an object is created. Its entire job is to initialize the object and make sure it's in a valid state from the get-go.
So this is our old way, the before picture. You can see it's a 3-step process, 3 separate lines. That means 3 chances to mess something up. It's just fragile.
And now, look at the after. With an init method, it's just one beautiful, clean, reliable line of code. We pass the coordinates in right when we create the object. The most important part here is that it is now impossible to create a point object without giving it coordinates. It's one single, foolproof step. It's a massive improvement.
Okay, we've pretty much perfected our point blueprint. So let's zoom out a little bit and see how these classes fit into the bigger picture of a real Python project. The organization is actually quite simple. You've got your classes, the blueprints, you write those classes inside a .py file. And in Python, that file is called a module. And then when you have a bunch of related modules, you just stick them in a folder. And that folder becomes a package. That's it. That's how you keep even huge projects from becoming a total mess.
One last really important topic is data privacy. Now, other programming languages have very strict public and private locks on your data. Python's philosophy is different. It's all based on convention, kind of a gentleman's agreement between programmers. A single underscore, like underscore name, is a polite hint that says, hey, this is meant for internal use, you probably shouldn't touch it. A double underscore, underscore name, is a much stronger suggestion. Python actually renames the attribute internally to make it harder to access by accident. But here's the key. Nothing is ever truly private. Python trusts you, the developer, to be responsible.
So we've gone from a simple analogy about a recipe and a cake all the way to understanding the core components of object-oriented programming in Python. A class is the blueprint, an object is the thing you build from it, and with these tools you can model almost anything, from a point on a graph to a user in a web app. So the only question left is, now that you have the blueprints, what will you build?